Hey everyone, let's talk about something that's been quietly revolutionizing Alzheimer's research, and it's not what you think. Most of us have heard about amyloid plaques and tau tangles, right? But here's a twist. What if the real story isn't just in the gray matter, but in the white matter? I'm talking about the brain's wiring, the stuff that connects everything. And guess what? A new metric called PSMD is flipping the script on how we understand this disease. Let me break it down for you. Now, I know you're thinking, wait, white matter? Isn't that just the background noise in brain scans? But hold on. This study out of Spain is showing that white matter damage shows up way earlier than we ever imagined, especially in people with Down syndrome. And here's the kicker. They're detecting these changes at around 38 years old, 15 years before symptoms even appear. That's like spotting a storm on the horizon long before it hits land. What does that mean for early intervention? It's a game changer. But personally, I think this raises a deeper question. Why have we been so focused on grey matter all this time? What's been missing in our understanding of Alzheimer's? Let's dive into PSMD. It's this fancy acronym for peak width of skeletonized mean diffusivity, but don't let that scare you. Essentially, it's a way to see microscopic changes in white matter that regular MRI scans miss. Think of it like a super-sensitive thermometer for the brain's infrastructure. The researchers found that PSMD levels spike in people with Down syndrome way before any visible lesions show up. And here's what's fascinating. This metric isn't just picking up on damage, it's linking it to cognitive decline. In other words, it's not just seeing the problem, it's connecting it to the symptoms. But what many people don't realize is that this isn't just about Alzheimer's. It's about the tangled web of vascular issues, inflammation, and axonal damage that's been under the radar for decades. This study is like shining a flashlight into a dark room and realizing there's a whole ecosystem of problems we didn't even know existed. Now, I want you to picture this, a person with Down syndrome. Because of that extra copy of chromosome 21, they're wired to accumulate amyloid much faster. This makes them a perfect model for studying Alzheimer's, right? But here's the thing, this research isn't just about them. It's about all of us. If we can spot these early signs in a high-risk group, imagine what that means for the general population. It's like having a crystal ball for brain health. But let's be real, this isn't a magic bullet. The study's authors are clear, we need more longitudinal data. They're comparing different age groups, not tracking the same people over time. That's a big difference. So while the results are exciting, we have to temper our enthusiasm with caution. This is science, after all. It's not about jumping to conclusions but about building a foundation for future breakthroughs. And here's another angle. PSMD isn't just a diagnostic tool, it's a potential monitor for treatment effectiveness. Picture this. In the future, when we have drugs that target amyloid or tau, we could use PSMD to see if those treatments are also preserving white matter integrity. That's not just helpful, it's essential. Because if we're only looking at plaques and tangles, we might be missing half the story. This metric could help us tailor therapies to individual patients, not just slap a one-size-fits-all approach on everyone. But what this really suggests is that Alzheimer's isn't a single disease. It's a complex interplay of factors, and we've been looking at it through a narrow lens. Time to widen that lens. So where do we go from here? Well, the researchers are already hinting at the next steps. More studies, more data, more validation. But for now, this discovery is a reminder that the brain is far more intricate than we give it credit for. And if we're going to fight diseases like Alzheimer's, we need to stop thinking in silos. We need to connect the dots between neurodegeneration, vascular health, and inflammation. Because in the end, the most powerful tools aren't the ones that tell us what's wrong, they're the ones that help us see the whole picture. And if you ask me, that's exactly what PSMD is doing. What do you think? Should we be rethinking Alzheimer's research entirely? Let me know in the comments below.